Hey guys, this is day 2 of Unit 1 matrices. Today our task is to work through matrix multiplication. So in this task, we are going to be walked through several of the steps that it takes to do matrix multiplication. And one of the big things that you have to know is this key little note right here. In order to multiply the matrices, we first have to know the matrix dimension. So in this first example, we have 2 rows by 3 columns. The next one is 1 row by 2 columns. The third example is 5 rows by 1 column, and the last one is 4 rows by 2 columns. Okay, the reason that that is important is because we have to have a matchup of columns and rows from one matrix to another in order to multiply them. Okay, so to determine the next element, and again, we already have the solution here, we're going to walk you through the steps. So I want to determine the value of row 1, column 2. So we are going to multiply row 1 of the first matrix by column 2 of the second matrix. And again, you'll see that work below. We have 5 multiplied by 4 plus 3 multiplied by 3. So 5 times 4 is 20, plus 3 times 3 gives me the 9, and that's how we get row 1, column 2 to have a value of 29. As we continue on, we'll do the same process. I'll walk through these just a little bit faster. You can go back through and read all the nitty-gritty details if you need to. So this case, we are going to multiply row 1 by column 3 in order to get the row 1, column 3 element, which should equal 33. So 5 times 6 is 30, and 1 times 3 is 3. Okay, so that does give us the 33. That is row 1, column 3. Now you're done with row 1. You don't have to look at it anymore. So actually, when you're determining the elements of row 2, if it helps you to cross off the row 1 from that first matrix, by all means do so to kind of help you keep tabs on what you're looking at and what you're working with. So we now need to determine row 2, column 1, row 2, column 2, and row 2, column 3, so we can get these last final elements that we need. So row 2 multiplied by column 1, 2 times negative 1 is negative 2, plus negative 1 times 4 is negative 4. Oh, excuse me, I multiplied wrong. That should be 2 times 1 is 2, and negative 1 times negative 2 is positive 2. Excuse me, I was looking at the solution. So that gives us a value of positive 4 for row 2, column 1. Excuse me, gang. All right, now we're going to take row 2 and multiply it by column 2. Dang, I did it again. I highlighted the wrong one. All right, here we go. By column 2, there you go. So 2 times 4 is 8, and negative 1 times 3 is negative 3. So 8 minus 3 would give me the positive 5 for this next element. And then last but not least, we are going to take row 1 and multiply it by column 3. So 2 times 6 gives me the 12, and negative 1 times 1 gives me a negative 1. So 12 minus 1 would give me 11, and that is the final element. So you'll notice our 2 by 2 matrix, when multiplied by a 2 by 3 matrix, because those interior columns and rows matched, give us a product which have dimensions of a 2 by 3. Again, those are the outsides, the leftover rows and columns that give you the dimensions of the product. All right, so these are just a couple to double check. Can you multiply? It doesn't matter what the elements are. So we have a 4 by 2 multiplied by a 2 by 5. These inner elements match the columns of the first multiplied by the rows of the second. Therefore, our product will be a 4 by 5. It does work. We can multiply. Our next one, we have a 1 row by 3 column, a 1 by 3, multiplied by a 3 by 2. Again, the interiors match. That's good. So we can multiply this, and the product will be the outside pieces, the 1 by 2. So that one would have 1 row and 1 row and 2 columns, just like that. All right, our next examples in the bottom do not have interior elements that match. The rows from the second do not match the columns from the first. So a 4 by 2 and a 2 by 4, they do not match. So this, you could say, is undefined, can't be multiplied, kind of really however you would like to say it. And same with the next example, we have a 1 by 3 and a 2 by 3. The columns of the first do not match the number of rows for the second. So again, this cannot be multiplied. All right, the last two examples are the same thing we're talking about. Once you've determined that they can be multiplied, the columns of the first match the rows of the second, then the exteriors, the outside pieces, give you the dimensions of the product. And I've said that several times already. This is just another generic example just to prove that it is true. Okay, in this notation that we have at the top, we're discussing the notation for the element or any given element of the matrix. And I've kind of written it already where I've written row 1, column 1. But what they're saying in this example is just kind of an easier way to do it is you could just write whatever the value is. So the O's stand for order or, you know, whatever you want them to stand for. If it's a subscript of 1, 1, that means row 1, column 1. If it's a subscript of 3, 2, then it means row 3, column 2. So it's telling you the placement of each of these. So if I said, what is the placement of the element 5 in the matrix that's given, you would tell me that it is the element that has row 2, column 3. There you go. That would be its order or its placement. All right, in the example that we have below, it's referring back to Devonte's Deli Delights, and we actually don't have that information written here. It's on the next page, so I'm going to go ahead and tell you the information. So the order matrix, so how many orders were placed for Saturday and Sunday at Devonte's Deli Delights, gives us a matrix of a 2 by 3. And the ingredient matrix for how we're making each of these lovely sub sandwiches turns out to be a 3 by 6. So our question that is asked is, should we multiply the ingredient matrix by the order? So should I do a 3 by 6 multiplied by a 2 by 3? That's the ingredient multiplied by order, question mark. Or should we do the order matrix multiplied by the ingredient matrix? And in that case, our order matrix is the 2 by 3 and the ingredient is the 3 by 6. Okay, and then it says why, how come? So this is asking you to remember what you've just practiced in several of the other examples and we've discussed thoroughly. So we're going to check the order multiplied, or the ingredient matrix multiplied by the order. Do the columns of the ingredient matrix match the rows of the order matrix? No, so you cannot multiply. Okay, does the other way work? Do the columns of the order matrix match the ingredient of the ingredient matrix? Yes, so you can multiply the order by the ingredient because the columns of the first match the number of rows of the second. And in example 2, we're actually going to carry out that multiplication. So here is our order matrix. So this is our 2 by 3. of the orders that were placed on Saturday and Sunday. And the next one is the ingredient matrix, all the ingredients they use to make these subs, which is a 3 by 6. So remember, when we multiply these, a 2 by 3 multiplied by a 3 by 6, our final solution, our product, should have dimensions of a 3 by 6. So I need, a 2 by 6. I said the wrong and wrote the wrong thing. Remember, the ones that are on the inside, the 3's match, so I take the ones on the outside. So I need 2 rows and 6 columns to get each of my values. So I'm going to start with row 1, column 1. So row 1 multiplied by column 1. That's going to give me 12 times 2, which is 24, plus 55 times 2, which is 110. Plus 6 times 2, which is 12. Find the sum of those, which will be 146. There we go. Now I'm going to take row 1 and multiply it by column 2 to get row 1, column 2. Each of these are going to be multiplied by 1, so that'll be 12 plus 55 plus 6. So 12 and 55 is 67, and 67 plus 6 would give me 73. Okay, now I'm going to take row 1 and multiply it by column 3. Row 1, column 3 is the exact same values as row 1, column 2. 12 plus 55 plus 6, which would give us 73. We're then going to take row 1 and multiply it by column 4. Row 1, column 4. So 12 times 1 is 12, 55 times 0 is 0, and 6 times 1 is 6, so that would give us 18 for row 1, column 4. We'll then do row 1 multiplied by column 5. So row 1, column 5. 12 times 0 is 0, 1 times 55 is 55, and 1 times 6 is 6. Find their sum to get 61. And last but not least, and then we'll be all done with row 1, column 6. 0 times 12 is 0, 1 times 1 is 55, and 1 times 6 is 6. That has the same value as the column just before it. All right, we are done with the Saturday information, which was row 1 of the first matrix. And now we'll do the same thing, but we'll do it for row 2, column 1, and so forth. So we're going to take 10, 3, and 60 and multiply it by 2, 2, and 2. So that would give us 20 plus 6 plus 120. Yep. So that would be 146 again. All right, our next one is row 2, column 2. So row 2, column 2, each of those elements are multiplied by 1. So I'll have 10 plus 3 plus 60, which would be 73. Again, if you notice, the elements of row 1 and column 3 are the same as before. Row 2, column 3, the same as before. So 10 plus 3 plus 60 to give us 73 again. We'll then do row 2 by column 4. Row 2, column 4. So 10 plus 0 plus 60 would give us 70. And we will now hit up one of the last ones, row 2, column 5. So row 2, column 5 is 10 times 0 is 0, plus 3 times 1 is 3, and 60 times 1 is 60, so that gives us a sum of 63. And just like the last time we did this with row 1 information, row 2, column 6, row 2, column 6 is going to be the exact same value as the column before it, so it should have a sum of 63 as well. And there you go. A lot of multiplication. All right, so what is element A11 of D and what does it represent? Okay, so that means row 1, column 1 of matrix D. And it represents whatever that particular number is. Okay, I'm not exactly sure what that number is. What are row 1, column 4 and row 2, column 4? What do they represent? Okay, so they represent the elements of row 1, column 4 and row 2, column 4. And then in general, each element represents a given value for the particular information of the matrix. It just kind of depends on what your matrix is representing. In our matrix, we were talking about Devonte's Deli Delights, the orders, and the ingredient list. So depending on which one you're looking at, depends on what the element actually represents in a given situation. All right, so now you can practice some of this on your own. Worksheet B has matrix multiplication. Worksheet C is like an extra practice before you would take your quiz. So it'll have addition, subtraction, scalar multiplication, and some regular matrix multiplication that we just did today. And there are your due dates and things you can practice to get yourself ready for your first quiz.